Hi, everyone. Thank you very much for tuning into AWS Keynote at PaaS Data Community Summit. I am Adnan Ijaz. I'm Director of Product Management at AWS. One of the charter of my team is to make AWS the best place to run your SQL Server workloads in the cloud. We have had long-standing relationship with the PaaS Data Community Summit. Over the years, we have seen the community thrive and grow with the contribution from the technical contribution from our professionals, from our services. And this year, as a diamond partner of the summit, we are excited to bring a whole catalog of educational content to build your data solutions in the cloud. So today we're going to talk about how you build a modern data strategy and put your data to work using AWS services. We'll specifically focus on SQL Server. And then I will have a couple of customers come in to talk about their experience of running SQL Server, migrating and modernizing it in the cloud. So we will have Umar from Salesforce and Cam from Aries to talk about their own experience of migrating and modernizing SQL Server workloads in the cloud. All right, let's get started. A modern data strategy can help you manage, act on, and react to your data. But a data strategy is just means to an end. And what is the end that most enterprises desire? It's really the business outcomes. And what are those business outcomes? Making better and faster decisions, improving customer experience and loyalty, staying ahead of the competition by innovating faster, and then reducing cost. Let's take a few examples for each one of these. First of all, customers need to start by breaking down the silos, improving data quality, and making sure the data is accessible from all over their enterprise, so they can extract value of the data that is in the enterprise. Let's take the example of Australian swimming team. They had data in disparate sources. It was all scattered. The data for the players, the data for their trial runs, the data from the races, the benchmark data, it was in all different sources. So they started by breaking down those silos and bringing those data into a data lake, and then building machine learning and using analytics to predict who should be on the relay team and how should they build the relay team. The outcome of all of that, the solution was pivotal in helping Australian swimming team, relay team, to be one of the best teams in the 2020 Tokyo Olympics. Second, the right data strategy can help you improve customer experience and loyalty. For example, United Airlines improved the passenger experience by using our database and machine learning services to automatically validate travel documents and COVID test forms during the pandemic. Since the deployment of the AWS machine learning solution and the data solution, United has automated 66% of all documents and 75% of all COVID tests for all passengers during the pandemic. This has significantly improved the customer experience and reduced the manual effort by the United employees. Third, customers are using data-driven insights to innovate faster and outpace the competition. Cathay Pacific, an airline, moved their passenger revenue optimization system and other services to the cloud. In turn, it helped them streamline and innovate faster by speeding up their software development process by 67%. The net result is that Cathay Pacific is innovating faster, and they're using those freed up resources to add differentiated products and services for their customers. And last but not least, customers are optimizing their business processes with data and reducing operational cost. For example, Samsung migrated their legacy on-premises database system to the cloud and lowered their monthly cost by 44%. So the question is, how did our customers do all of this? The answer is by building a modern data strategy with AWS. And there are really three pillars to that strategy. How do you actually bring your infrastructure and data to a reliable, performant, and secure cloud? and not have to worry about the infrastructure utilization, infrastructure efficiency. So you unlock the value of cloud. Then unifying the data and breaking down the silos so you can reason over the data with the same lens. There is a single source of truth. And once you have those pieces, you can innovate and unlock the insights from the data and add more, customer experience related things, add more new use cases. And these are the three pillars of your modern data strategy. They don't necessarily have to be in a sequence. You can start anywhere, or you can be working on any of these pillars at the same times. At the same time, so then there is also a virtuous cycle. How if you more you modernize your data pipelines, better and easier it is for you to unify and innovate faster. So there's a virtuous cycle in all of it. But how do you bring these pillars, and what are the building blocks that bring these pillars together into a unified data strategy? And so this is really a high level overview of a modern data strategy in action. On one hand, you have data sources. The data can be coming from all disparate sources. You figure out how you store that data, relational databases, non-relational databases, how you do data warehousing, how do you run analytics, how do you leverage your existing business intelligence tool, unify the data into a single data lake, be able to use machine learning, predictive analytics, and all kind of other analysis to really innovate for on behalf of your customer, and then have the right governance and security control so that the data is secure in your enterprise. And then there are, on the right hand side, there are people and apps, there are devices that consume this information and help you make those business decisions. And then that cycle repeats, right? That more you have those apps and devices and more people are using your products, they are generating more data, thereby adding to more data sources. And that's how the cycle goes. So AWS offers you a full range of services to build this modern data solutions in AWS. On the data, your data might be coming from all disparate sources. It may be a third-party data that you want to use. You can use AWS Data Exchange that helps you discover the data. The data could be streaming from different devices. Amazon Kinesis allows you to bring that data in. Same goes for AWS IoT. You may have hundreds and thousands, millions of devices that's sending the data that you can process. Appflow allows you to bring data from all kind of different SaaS applications that you're using. So all these sources where the data is sitting, you can use these services to bring the data in, and then store it in relational and non-relational databases. Amazon provides over 15 different relational and non-relational database solutions that are tailor-made for your needs. That includes SQL Server running on Amazon EC2, Amazon RDS, Amazon Aurora, DynamoDB for NoSQL needs, and the list goes on. Then you have analytics services that allow you to run analytics and data warehousing on all kinds of different data sets. Then you can bring your own BI tools, or you can use QuickSights or EMR to analyze the data, to run big data analytics. You can build your data lakes using Amazon S3 and then run the governance and cataloging, all of that using AWS Lake Formation. And last but not least, you can use machine learning services such as Amazon SageMaker to build different machine learning models on the data that you have put together in AWS. You have unified and modernized with AWS. And these services are just some of this list is by no means a complete list. These services are just a small subset of the capabilities that AWS provides for customers to build their modern data strategy. So now let's talk about SQL Server. One of the reasons many of you are here is the SQL Server workloads. For many organizational relational databases, particularly SQL Server is an important part of their data strategy that they want to put together. At AWS, we have been helping customers simplify their SQL Server transformation to the cloud since 2008. And we have seen our customers migrate and modernize their SQL Server workloads in AWS to address the cost constraints, which comes with the commercial grade databases to optimize their usage. And we've been doing it since 2008, before many cloud providers even existed. So some of the reasons that customers choose to use SQL Server on AWS: uh, lower TCO. AWS provides better price performance for the same kind of workloads compared to the next largest cloud provider. High performance and reliability, close to 2x better performance or speed for running the same SQL Server workload in AWS. You have all kind of flexibility in running your licensing options. The easy to use management with the managed services like Amazon RDS, giving you flexibility to defer your undifferentiated heavy lifting to the cloud. Broadest and deepest capabilities, over 14 years of experience running SQL Server in the cloud. And then great security and identity services. The thing is, like the database, often we think SQL Server as one thing, one part of the solution. But in reality, you need all kind of services and the entire ecosystem to be able to consume that data, to be able to build insights. So having services and the ecosystem that is broader, that is rich, is critical for that. So up to 5x more services that have encryption, compared to the next largest cloud provider, giving a more secure solution, more secure options to build your data solutions. So here's a benchmark. A third-party Principal Technologies ran a price performance benchmark for SQL Server workloads in AWS compared to Azure. And what they found out that AWS provides up to 2x better speed at 68% lower cost. And this goes kind of counter to what you might have heard. A lot of FUD is being generated and put it out there that AWS is more expensive than some other options and whatnot. But the reality is, when you get into the details of what it takes for you to run your workloads in a reliable and performant manner, often it turns out that the AWS is much cheaper than the other options because of all these price performance advantages, all the reliability, all the latency improvements that we have added over the years. So when you put it all together, customers often find out that running SQL Server on AWS is much cheaper than some of the other options. Now, let's face it, licensing is a big part of your cost equation. This is also part of how you run SQL Server in the cloud, because you have these licenses running on premises. So AWS provides you all kind of licensing options that you can use to bring your SQL Server workloads in the cloud. You can buy these licenses from AWS in license included form and follow a pay-as-you-go model. No Microsoft agreement required, no administrative overhead of managing images or anything. Or you can bring your own licenses to AWS. There are a few considerations though. If your licenses have software assurance and they are qualified for license mobility, you can bring into EC2, Amazon EC2, and run it in our shared compute without worrying about any other issues. Or if you do not have license mobility, for your qualifying licenses, you can also run on dedicated host. And then we offer services like AWS License Manager that allows you to make sure that you are tracking your licenses closely, so you are actually staying within your limits of how much license you want to use. So that makes it easier for you to when the licensing true ups come in or the audits come in, you have peace of mind that your data is there and you have been running it in the most optimal and compliant manner. So what are your options for running SQL Server in AWS? There are really, at a high level, three options. One is you rehost your databases to Amazon EC2. This is the simplest option. Lift and shift allows you to use Windows or Linux. You have full control on your infrastructure. You will have to do the maintenance of the OS and the application and manage the scaling. So a lot of customers, when they are looking for just lifting and shifting their workloads and they want control, over their workload, they start there. Just rehost whatever they have running on premises or elsewhere, bring it to EC2, and start there. But a lot of customers also want to defer this undifferentiated heavy lifting to the cloud provider, so that they don't have to figure out how to patch their instances or how to back up those the database. So for those, Amazon RDS is a great example. You can is a great solution. You can re-platform your SQL Server to run on Amazon RDS. It's a fully managed offering, allows you to free up those resources that you would typically use to manage infrastructure, to add the value added, to deliver value added services to your customer. The important part with Amazon RDS is there are always some applications where you like, I do want to run it in a managed experience, but I wish I had some control on the underlying operating system, to install additional software, maybe install things like SharePoint. Amazon RDS allows you the option. So there's a fully managed solution, and then Amazon RDS also has a custom solution that allows you to perform those management tasks on instances for the set of use cases which require you to have access to the underlying instances. So really full range of options to meet all kind of needs that you might have for running your SQL Server in the cloud. And the last but not least is you refactor to the purpose-built databases. Oftentimes you have databases, you're building solutions that require millisecond latencies. Those are solutions that require purpose-built databases. You can, even for relational databases, you can use the open source alternatives like Amazon Aurora for commercial grade relational databases, to replace them at the really cost of 1/10 of a commercial grade database. So those are an option for you depending on your use case, what you want, so you can refactor your databases to a modern open source version. So now, in addition to building services and technologies, which we have talked about, how these are all building blocks for you to put together a data strategy, AWS also offers you a comprehensive set of programs and incentives to successfully run your SQL Server workloads in cloud. And my personal favorite is what we call the program called OLA, Optimization and Licensing Assessment. The reason this program is really my favorite is, using OLA, we work with our customers to look at their usage of Microsoft workloads, specifically SQL Server, and we also understand how they are running that workload. Is it optimized? Are they using all the licenses they have? And we really help them figure out what is the most optimal way for running that workload in the cloud. And this is really the reason I like this program, is because this is really customer obsessed. We're not thinking about selling more licenses to customers or telling them that to use a configuration that is not optimized for them. So for us, it's all about looking what they have running, how they are running, and how they should be running in the cloud so that it's an optimal configuration. And we have a whole range of customers who have benefited, who have actually reduced their costs significantly coming from on-premises or other places to run in AWS by leveraging programs like OLA, where they find out that there are better optimal ways for them to run these database workloads. And OLA has been a key contributor to helping customers find those cost savings. Then comes our migration acceleration programs. It's really a comprehensive set of the tools, processes, guidance, professional services support to help you migrate your workloads, Windows, Microsoft workloads, including SQL Server, to the cloud. And then we have database freedom. On the last slide, I talked about how you have sometimes need to run commercial grade replacement for relational databases in an open source format that custom built databases. So database freedom program allows you to leverage those custom built databases for your application use cases, so that you can get millisecond latencies and you can get reliability and then reduce costs. So we talked about a whole range of different products and services. I cannot get into all details, but there are a couple of new products that we recently launched. So I'm really excited to bring those to you and talk to you about those. First, we recently launched AWS Migration Hub Orchestrator for SQL Server. So Migration Hub, AWS Migration Hub is a single place for you to discover all your servers, plan and track migrations, and track the progress of those individual servers. So last year we launched Migration Hub Orchestrator that helps you migrate your SAP workloads to the cloud, because these large migrations, often there are multiple steps involved, there are multiple individuals involved. So how do you track those workflows is really what we attempt to solve with the Migration Hub Orchestrator. So now we are adding that support for SQL Server migrations. You can accelerate your migrations with predefined workflow templates that we have built using our professional services, using our solution architects who have performed these migrations over hundreds and thousands of customers. So how we build those best practices in the template so that you can use those. So you can track the migrations of those workflows in one place, and then you can re-platform these workloads to RDS, or run them in EC2 using backup and restore capabilities. So it really streamlines your SQL Server migration to AWS. The next one, I want to talk about Amazon RDS Proxy. So RDS Proxy is a fully managed, highly available database proxy service that is between your application client and the backend RDS databases. So why it's important? So as you build more applications, especially the serverless applications, you are opening lots of database connections. You are closing those down. You are consuming those database memory. You're using those compute resources, which is not really optimal. So with the RDS proxy, it allows you to pool your database connection and use across. And by doing so, you can leverage the IAM application, the access to your database connection, so you don't have to carry the credentials, you don't have to store elsewhere. So it's really more secure, and it's also more streamlined so that you are saving resources for building especially serverless application. And today we are announcing the general availability of RDS proxy for SQL Server, so you can actually build modern data applications with SQL Server as your database engine, and then you be able to use RDS proxy to build that solution. So now I would introduce you to Umar Jaber, who is the engineering principal architect at Salesforce, and he will talk about how they are completed the SQL Server migration to AWS, and then followed by Cam, who is VP of Product and Aries, who will take us through his experience of building data applications in AWS.
Thanks for the invite to speak about Marketing Cloud AWS migration. My name is Omar Jaber, Principal Architect Software Engineering at Salesforce. Marketing Cloud and Engagement is our digital engagement platform, our Marketing Cloud for Salesforce. In summary, it's a platform that provides capabilities of reaching our customers, reaching mass amount of people, our consumers around the world over multiple channels, being able to run campaigns, to tune these campaigns, to reach our customers, as well as learn from how the customers use our product and respond to their campaigns and tune that campaign. Marketing Cloud Engagement Platform is used around the globe, and in Cyber Week is sort of our biggest week. Last year, the scale of this environment across email, mobile push, WhatsApp, which has been with us for a while, has reached over 1 trillion annual messages in 2021. We sent about 33.4 billion messages, emails in 1 week. So in Cyber Week, that's an increase 25%, 7.2 billion messages of mobile notification, 94% increase. And our AI, which takes your campaign, tune it based on customer engagement events like opening clicks, has produced over 140 billion daily AI predictions to help our customers. All that, and we maintain 4 nines availability. All that scale, and we decided to take this platform from first party on-premise to AWS using Salesforce Hyperforce platform. Marketing Cloud today has a global presence. It's deployed mostly in Europe and United States. And our over 12 stacks and first on-premise, we deployed two more production stack after our transformation to AWS, one in India and one in East US. In FY24, we'll increase this presence around the world. Wherever there is an AWS stack, we'll be able to deploy our marketing cloud. Our partnership with AWS has started a while back with CRM integration a few years back, and it's been incredibly successful. We like the pace of animation and the new solutions AWS provides and the trusted infrastructure that AWS provides, from the availability zone to strong networking and backend storage, continuous innovation, as well as reliability. We maintain a set of architecture principles that are critical to our transformation. And one of the couple of ones that we'll go through this presentation that are critical for our transformation that I'd like to share is around data encryption and zero trust. We host our customer data from around the world, and it's critical we keep this data secure and ensure our customer success by securing their data. These principles, from everything as a code to observability and high availability, are incredibly important to Salesforce. But encryption and zero trust is just equally as important, and it was part of our transformation from day one. Later on the slides, I'll touch base on a couple of the concepts that we developed early in the migration process to ensure that happens accurately. As part of our transformation goal, taking our marketing cloud engagement platform, which is a world-class digital engagement platform, to AWS, we wanted to do it in 12 months, and we had critical transformation goals that we would like to achieve. And it's important that in the stage of the transformation that you maintain these goals and you set a standard for them, so you know that as you are progressing your transformation, you're achieving your goal. For us, some of the more important ones that we carried on from our Hyperforce platform, like, for example, zero trust architecture. Critical ones were on-premise feature parity was important. We don't want to change the business logic and impact our customer solution. We wanted to adapt zero trust architecture and maintain one code baseline. Every day today, our code get deployed in 12 data centers on-premise, as well as on 2 data centers on AWS data centers. And this will continue as we deploy more AWS data centers and we migrate our customers across to the cloud. This diagram is a sort of an overview, a high-level overview of our engagement platform. You can divide it to about 4 major areas, which is the application layer, the inbound layer, the data tier, and the outbound. The core business logic sits in a compute cluster that runs the customer core business logic, whether it is an engagement that the customer runs, like campaigns, whether it is a messages of trigger sense that the customer calls our inbound API and sends the message, or it is sort of an application UI the customer interacts with. The data tier itself consists of multiple different parts of the system, but majority of the data sits in our SQL Server database. The database is probably the second largest database deployment app after Microsoft. We deploy other data tiers, but SQL Server runs the majority of the business logic for the customer. Looking at this, scaling the compute, scaling the storage, deploying the inbound, outbound servers are not critical for us during the transformation. The data tier and the business logic that runs on the data tier of the SQL Server was considered to be sort of the biggest risk for us as we transform. And this is where we started our sort of migration research. We identified, looking at it, is our database tier is our primary and most critical service of everything. All other services depend on it. In the last holiday season, we executed over 3 trillion transactions during the Cyber Week. We carry hundreds of petabytes of data, of relational data we run, and 3 trillion transactions on top. So there's considerable amount of workload in the database, and its success means our customer success. There are a lot of scale factors when you're migrating from one platform like AWS to AWS platform from first party. Different hardware, different storage solution, different networking. So obviously CPU, memory, and IO plays a role. But this can be mapped correctly as you look at the specs. What we found, and they won't mimic the application utilization as much as for a database and how the application uses the database, as much as database IOPS, log write throughput, log size, and database. So we wanted to develop a model that would say, assuming that we maintain the CPU memory and IO, how can we sure that we can actually compare apples to apples between what we deploy in AWS and what we deploy in first party? And we scale the system. So we designed a model of scale factors. And we picked the 4 scale factors we picked, the one I'm going to go through, that help us understand how we model the system. The first one was database size. It's critical. When we modeled our database sizes, we found our customers, the majority of our customers will fit below 80% of them below 100 terabyte. And that's critical for us because we want to understand how fast they grow and how should we shard the data files. The growth of a data file, the sharding of the parallel writes of the data file makes all the difference of database performance. So that was the first scale factor we went through. The second one was log size. Database log file is critical because longer running transaction will hold the log open and it gets bigger. And you wanted to understand out of it, what is the peak versus the sustained? In this case, it happened the max write throughput in megabytes per second. This has happened to be the peak. We wanted to also see the sustained. We run at about much lower when it comes to sustained, but our peak was also the critical path that allows us to run the billions of messages that we execute and serve our customers. So we wanted to, when we approached this and looked at the log file size, we said, this becomes a risk for us. And the risk is when you're recovering a database, log file size matters, as well as how can I transform to reduce the overhead of log file size? Means move transactions, large transaction, long running transaction, and reduce them. So this was another scale factor that we determined that we need to keep in mind as we transform the application. The third one is scale factor is log write throughput megabytes per second. Now, ability to write a lot of data is log write throughput per millisecond. So, I mean, this is ability to write the larger the log file size of log, the larger I can write. Now, SQL Server, regardless of how many log file you give it, it will still it's serialized. In other words, SQL Server will go and fill up a log file at a time, but it will eventually, but it's all serialized. So we looked at our peak and looked at our P99 of log write throughputs. And we determined that although our sustained workload is far less than 100 megabytes per second, our peak and closer to the P99, which is, your peak customer, your large customer, would peak around 250 to about 350 megabytes per second. And that's, for us, that means when we design the storage solution, the ability to write that much data, we have to take that into account and how we pack our databases. If we put a lot of databases in the same shared EC2 instance, and we max out the instance log maximum throughput, that will impact the customer's throughput. Therefore, as we move our customers from first party to Hyperforce, we have to understand our customer workload, have to position correctly in AWS. The last one is database IOPS, which is basically, this is both data and log. You're writing a lot of logs, writing a lot of data. We talked about parallel writing to the data files. We talked about also reducing the log write throughput. But how many IOPS, how many executions it takes to write that amount of data is an indication of either you have a balance between not too extreme of long running transaction or too many micro transaction that result in writing too little data, but executing too many transactions. We started earlier. This probably, although it's a scale factor number 4, but we started in this one much earlier, analyzing it, given the fact that IOPS can be a considerable overhead. For us, the max IOPS was way beyond 300,000 when we started, and we reduced it below 160,000, 175,000, around that time. This allowed us to optimize it in the way we set it up on AWS, picking the right EC2 instance, picking the right storage, as well as ahead of the migration, do the optimization we need to minimize microtransaction and improve the overall throughput of the writes. Eventually, the final solution for us was we went with a managed instances at EC2 on IO2 block storage, and our solution was deployed on as an availability group on Windows Server. And we picked 3 availability groups. Of course, we positioned everyone in their own availability zone. So a database, when it's deployed, it will have 3 replicas, 1 primary and 2 replicas. And these allows us to do a failover between availability zones in the case of an immediate failover. Now, we also can maintain a remote replicas in different regions for backup and for DR scenarios. That's an option for us. And we maintained well below 10 seconds of sync between the primaries and replicas, even at peak load. Our synthetic load testing had showed well below 10 seconds of synchronization. This allows us to do instantaneous failover between the primary and secondaries across availability zone and provide a highly available solution to our customers. A project like this and the complexity of the project means you have to layer the project such that it's an achievable phases. Otherwise, it becomes difficult for you to achieve the entire complexity of making the data to your work, the compute to your work, and the rest of the application. You're carrying a legacy application from first party, moving it to public cloud, identity model, authentication, authorization, data structures. All of that comes into play. So phasing for the project build up is critical for you. For us, we started by building our basic fundamental services on Salesforce AWS Hyperforce platform. Then we moved to building our engagement foundation services, which is including the data tier and other storage, authentication, authorization, role-based access. I'll go that a little bit more in the next slide. And then we start building the application, eventually deploying a development test stack, and eventually start building until we got to the production stack. Service layering is important. It guides both your development as well as your deployments. We started from the basic principles by providing the basic services like CI/CD, automation, monitoring, and logging, and then building a layer. Every next layer builds on top of the layer below it, allowing the engineers, as they get involved in the project, to find complete services and layers available to them so they can actually utilize them to build the next services. For us, the data tier was critical, the next, and the identity model. From there, we moved to secret management, role-based access, and then the application business logic, tooling, and diagnostics. Earlier, we mentioned that an engagement platform, the size of marketing cloud engagement platform, is what hosts customers' data, and it's our customer. It's a customer's data, not ours. It's critical for us to ensure that as we move platform, every single change is design reviewed and security approved to ensure that there's a lot of changes happening and ensure that we don't cause by mistake something. So we put a development cycle from day one, and every existing service has been design reviewed. Once it passes a design review, it goes through a security and architecture review, and only then, once it passes both the design and security review, it'll start the execution of the implementation and lift and shift onto AWS. On that one, any design we developed has to meet one code base, has to have a clear cost to serve model, has to have a clear and well-documented threat model, and our Salesforce Hyperforce compliance model. As you build a complicated service from first party to public cloud, a lot of assumptions usually made around networking and security within your own data centers, and in public cloud it differs. We wanted to achieve zero trust architecture. So what we took all the nodes, all the services types that could be involved, and all the communication protocol and how they authenticate and communicate, and we ensured that whether it is always encrypted communication through MPLS or role-based access across the services, is completely covered, ensuring that our customers, when they are running on public cloud solution, have ensured that their data, as well as every single communication between within our services, is always going through a dual authenticated connection. During our transformation, we had a close relationship working with the AWS team, and they provided from a deep technical skills to the professional ProServe team who worked with us for over 18 months to make this happen, from the research phase all the way until the deployment to production phase. The result, we managed to get the product transformed and in production for 14 months, from concept to production. 160 services run on first party as well as on AWS on daily basis. We produced 150 designs. They've all been design reviewed and security reviewed. 100 plus security assessment completed. That includes, of course, the usual penetration testing to ensure the product safety. And we deployed 2 production stacks. It's been an amazing experience working in AWS and transforming in it. And between the solutions they provided to us and between being able to take a large scale engagement platform from being in a couple of regions to anywhere there is an AWS stack in 12 months, it has been a phenomenal experience. Thank you all, and thank you for providing me the chance to speak today.
Thanks, Omar. Hi, I'm Camden Iliff, Vice President of Product for Aries Software, and I'm here to share a little about our modernization journey that have resulted in the largest technology and knowledge shakeup in our company's 27-year history. But before we get into the details of that journey, let's ask some questions about your company and your products. Have you been around so long and solidified your customer base so well that you don't have to worry about losing customers, even if you can't deliver new features and enhancements as quickly as new competition in your market? Probably not. Is your code so well written that you never create new bugs as you adjust your systems today? Probably not. And finally, is your platform so well designed right now that it can scale to meet your company's long-term objectives and operate with high levels of profitable efficiency? Probably not. Now, I ask you, can you afford not to modernize your systems and be ready for the future? For Aries Software, the answer was clear. No, we cannot. So let me give you some background on my company. Aries is a student information system, meaning we have an enterprise-level application to manage almost all the data that drives schools. This ranges from enrollment and classes, transcripts and attendance, and we have various mobile apps for teachers and parents as well. When we started, we were working with schools who did not have internet access and barely had local area networks. Our solution was built around the technology capabilities of our customers at that time, which was a local Microsoft Access database on a file share with a client app. But since then, we have undertaken 4 major modernization journeys as technology, customer expectations, and the competitive landscape have changed. Adapting to these shifts over our first decade in business allowed us to become the most widely used student information system in California. And now we support over half the students and schools in the state. But we are not done. In our identified growth markets, we want to achieve market dominance by 2030. And in our existing markets, we want to open opportunities that have been closed to us in the past and expand to 2/3 market share or more. And beyond the markets that we currently sell our products in, we seek to be a leader, not just in technology, but a leader in K-12 education. We will meet our goals by looking at the long game. Our company has done well these last 27 years, and we want to make sure we continue that trend far into the future. Our goals are not about short-term profits. Those are nice, but we focus on long-term success and sharing in the goals of our customers. To do this, we must stay ahead of the game. We must see the trends and adapt before our competition does. We must do more than just accept change. We must embrace it, and we have to drive it forward. These philosophies must be applied at all levels of an organization and to our product. Now, let's take a look at where my product was before we started our most recent modernization journey. We were running a fairly normal setup with IIS, running .NET, with some web forms and MVC, and we had a custom entity framework behind all of that. I'm sure that's pretty familiar to a lot of people out there. It stored data in a Microsoft SQL database for each customer. Some of our customers were self-hosted on their own servers that were at each school district, but most had moved to our hosted services, where the same configuration was actually adapted to the cloud. But when I say adapted, that is not equivalent to optimized. We built automations to streamline deployments and set up tools to monitor the system, that the system was functioning well. But basically, it was just IIS and SQL running on EC2 instances. It had very little ability to scale. In addition to that, it was expensive and highly prone to outages caused by just a few customers that were overwhelming the servers, or a minor bug having way more impact than it should have. To mitigate these issues, we built out more servers and isolated customers in their own environments. But this created an increase in SQL licensing costs, and our AWS costs also rose as we added more fixed EC2 instances. Sure, we could have made small adjustments and patches to create marginal improvements, but in the end, we chose to rewrite everything from scratch as a cloud-only application. As you look to completely redesign and rebuild the software application that is the core of your company, you have to really make sure your decisions are sound and based on the long-term goals of the company. For us, we knew that we needed to choose technologies and methodologies that would last us at least 10 years. This level of investment is not something we can afford to do frequently. This meant choosing systems and methodologies that had both been around a long time, long enough to be able to be stable, but were modern enough to last a long time into the future. We wanted systems with strong community and vendor support, but were progressive enough to attract and keep top talent, excited about the technologies they got to play with on a day-to-day basis. We were also focused on the scalability and stability of our systems. The first real decision was to choose a cloud platform. For us, the answer was easy: AWS. In our research, we found that AWS was at least 12 to 18 months ahead of their competitors in terms of capability and offerings. They were also focused on open source solutions and high levels of compatibility with standards. There was also a rich community of experts and an engaged company that we could partner with to bring our product to market. Our next decision was on a database platform. We selected Amazon Aurora with full MySQL compatibility, running on Amazon RDS. That's Amazon's relational database service. We also identified that in some situations, a document DB was going to be very handy and efficient for less structured data, and DynamoDB for key value pair lookups like user or system settings. We selected these two because they offered highly scalable solutions with high availability, but minimized the licensing and infrastructure costs. We also knew that if we needed to choose another database management system in the future, we could make that transition with minimal impact. Once the back-end platform was selected, we took a deeper look inside the database at what we wanted to change and what we wanted to keep. It might have been easy to use Amazon's database migration service, that's a DMS, to port our old data structure to Aurora, and use Babelfish to translate our old SQL to talk to MySQL. But we knew that a major part of our technical debt was wrapped up into this database design that used data models that could be traced back to DOS and even mainframe systems. You see, Aries was not designed from scratch back in 1995. It was actually based on an earlier student information system designs that our founder had created starting back in as early as the 1970s. So here we are, nearly 50 years later, needing to adapt new features and data collection needs around the system that could only support, well, originally 128 bytes per row of data. So it was time to give our system a fresh start. But I don't want to leave out all the other great AWS services we are using. Fortunately for us, we were able to engage with Amazon to kick off an AWS Modernization Lab, what they call an AML, where we worked with Amazon engineers to design the infrastructure that our application needed. What you see here is just a partial list of all the services we will actually use by the time this project is complete. These services are critical to making Aries successful because of the application architecture we are using. We originally decided to start building a lightweight monolith and tap into microservices like Lambda for operations that needed specific scalability. We went about a year developing that solution until we realized that in order to really achieve the level of performance and stability and scalability that we needed long term, that we should be using a full microservice architecture instead of just using selective microservices. As we pivoted into that direction, we had to also rethink our database design. Something I did not know before starting all this was that a well-designed microservice architecture requires that each domain have its own database. It's kind of like those sectional plates that they use at a barbecue where you can keep your beans from touching your salad. All the pieces of your application, including the data, need to be segmented into domains. This is so that each domain can scale independently and issues that may arise in one do not impact the entire system. So in this design, with dozens of domains, we have dozens of databases. And because we also decided to enforce tenant data security through differentiation of databases, that meant with hundreds of customers and dozens of databases per customer, that we're going to have thousands of databases when all of our customers finally migrate to this new system. And boy, doesn't that seem like a daunting task for a DBA? In fact, our own DBA team has the same concerns. With our classic software architecture, our DBAs who supported our customers were focused on creating custom reports and data flows. A few were tasked on system performance, of course, and maintenance, but for the most part, that was automated. Moving forward with our new designs, they will actually focus on the same thing. They will just be doing it in a different way. As I mentioned earlier, we also have customers who are self-hosted on the old system. Those school districts also have DBAs who are very used to working directly in that production database. They have built custom export and import routines. They have created scripts that clean up data and custom triggers that respond to certain data scenarios. The question is, how can similar needs be met when you move to a cloud-based, microservice architected, highly secure system. I can tell you one thing, it's not by giving people direct access to the operational databases. Instead, we are providing multiple ways to engage with our system in advanced ways. First, we're building a data warehouse. Two, actually. One will mimic our internal data model so that complex joins between domains can be achieved. The other will actually mimic our classic systems database design. We know it won't be perfect, but we are hoping for about 90% compatibility. This should or will reduce the burden to our customers and to our DBAs by simplifying the redesign of all the custom queries they've written over the years. And what is really cool is that with the event-driven architecture driving microservices, keeping the data warehouses up to date is just a matter of building that data movement code and tapping into the database update events in the production system. So these data warehouses will also be accessible to AWS Glue to transform that data and send it off to third-party systems that are being used by our customers. Next, we are publishing our entire API and wrapping it into an SDK that anyone can work with, so that anyone can work with any area of the system. This is how all custom database edits will be performed. DBAs will be able to write scripts or Lambda functions even to access information from inside or outside the system, and then use our SDKs to update data as needed. And all this done in a secure, controlled way. And for those customers who don't need extensive data transformations, we will be building in-app functionality to export and import data to and from, say, flat files on a scheduled basis. I know this all sounds super exciting, but I want to finish my story by sharing some key takeaways. My team and I have not been perfect. We have not made all the right decisions the first time. And I am confident that we will still discover more decisions we made weren't quite right. Hopefully, some of these lessons may help you on your journey. So first, make sure your people are ready. Learning is so important. Our people were experts at our old way of doing things, but this is all new, and we should really have spent many more months learning the systems and engaging with experts before we started coding. But we know waiting is really, really hard. But because once a decision has been made to move forward with building a new system, we want to jump in and we want to start writing code. But we really need to just be patient. Some decisions are two-way doors. We can walk through it and we can walk back easily, take a new path. But some decisions are much more difficult to take back, and you will have to live with those decisions for years to come. I would highly recommend engaging in an AWS application modernization lab. It will get you going on the right track. Second is plan. Figure out what it will take to actually do the work necessary for a modernization journey. Figure out how long it will take and with what amount of resources. We failed to do this and drastically underestimated the amount of time and effort it would take. In the end, we had to actually quadruple the size of our team and delay the release of this new product by 1 year from our original planned timeline. And absolutely do not forget about risk assessment. It seems a little interesting and odd, but it's incredibly valuable and important to finish, to work through. Next, adapt. You will absolutely run into roadblocks and problems along the way. You must be agile and willing to adapt to new information and circumstances. And when you start hearing yourself say the word hopefully, take that as a call to action to make sure that hopefully becomes reality. And as an example of this, AWS provides great resources to help you through this process, including the process this one describes, the assess, mobilize, modernize. And of course, contact your AWS account rep to get in touch with the right people at Amazon. They are really there to help you through this. I hope my sharing of Aries Software's journey has helped give you inspiration and guidance on how you can take your organization on its own modernization journey. Thank you.
All right. Thanks, Cam. Thanks, Omar, for taking the time and sharing your experience of running SQL Server in AWS. Just to recap, we believe AWS is the best place to extract value from data and turn it into insights. Hopefully, today's presentation gives you a starting point to go explore different pieces of technology and programs that we have talked about to find it for yourself. We're the most experienced cloud in helping customers build their modern data solutions, most reliable, scalable, and secure. And we offer the most comprehensive set of services that are needed to fully leverage the data that is present in your enterprises. So go discover that, use this presentation as a starting point, and happy exploring. In terms of next step, we are here at the PaaS Data Community Summit, and there are a nice lineup of sessions that you can go to dig deep into different topics, migration strategies, how to manage different your SQL Server deployments in the cloud, and how you can actually build those solutions. This list of events, I will leave it there for a few quick seconds for you to glance and identify which session you want to go to. And meet us at booth 401. We're also available online. My information is available there. Come visit us at the booth. We'll have subject matter experts. You can ask us questions, get your AWS t-shirt, get SQL Server book that you can use. And so thanks for listening. Thank you for tuning in. I am Adnan Ijaz. I hope you go explore building your data solutions on AWS. Thanks.